Morning, students.
Good morning, ma'am.
Screen is visible.
Yes, ma'am.
What we discussed in the previous class. Which topic we were discussing?
Pseudo code.
Abhishek, louder.
What's pseudo code?
I think we started with introduction to algorithm. Then we saw what is algorithm, what are all the steps available in algorithm. Then we discussed what is data and data structure, introduction part, and the classification of different types of data structures. So we know very well algorithm is a well-defined computational procedure that takes some value or set of values as input and produces some output or set of values as output. Algorithm is a logic or the procedure or function that can be converted into any program in any programming language. The coding can be done in C programming, C++, Java, or Python, anything. But the logic of the program is written or represented using algorithm. Data or data structure is given as input to the algorithm, and it produces the expected outcome, or it produces the what kind of results we are expecting. Algorithm is a sequence of computational steps that transform the input into output. If you take the other definition of algorithms, a tool for solving a well specified computational problem, or a problem specification includes what the input is and what the desired output should be. Algorithm describes a specific computational procedure for achieving the desired output. Any doubt with respect to the definition of algorithms? Say for example, if you want to write the algorithm for or design the algorithm for some sorting problem. So for the algorithm, the input will be a sequence of n numbers. The numbers may be in unsorted form. And we are giving the input to the algorithm. We are making the algorithmic steps in such a way that that produces the output, yeah, through a permutation of reordering the elements or numbers of the input sequence, such as, so the numbers will be ordered in A1 less than or equal to A2 less than or equal to A3 up to AN. So input is unordered sequence of numbers. The algorithm accepts the unordered sequence of numbers, and through the algorithmic steps, we are producing the output in the ordered form. An instance of the sorting problem: input a sequence of six numbers. Say we are taking six numbers as input, and the expected output will be the number is in unordered form 31, 41, 59, like that. But the ordered list will be 26, 31, 41, 41, an ordered sequence of output. So, any doubt? What is the role and function of algorithm?
No, no.
The first class itself we discussed in data structures. It's collection of various user-defined data types like linked list, queue, stack, array, hash, heap, graph, string, and we have a number of algorithms available that can be used along with the data structures to get the output depending upon the real-time problem. The various algorithms available that can be used along with the data structures of any programming languages can be classified into pattern searching algorithms, divide and contour algorithms, searching algorithms, sorting algorithms, bitwise algorithms, regression, recursive algorithms, backtracking algorithms, mathematical, formal language based algorithms, dynamic programming algorithms. We discussed this particular slide in the first class. So, any doubt in this particular slide? So far, we discussed what is algorithm, introduction to algorithm, definition of algorithms, what are all the functions the algorithms are performing, why we are using algorithms. The next topic is called algorithm design. So algorithm is a solution method, or it is an template. It is used to get the to solve the problems. So the algorithm can be designed according to the problem, or we can take the existing algorithms as it is, and that can be used in our projects to get the result, or we can design our own algorithm by taking the concepts and logic from different algorithms. A new algorithm can be framed according to the project or according to the program. That is called algorithm design. What is algorithm design means? It refers to the process of defining a step-by-step solution to the given problem. In general, we are using the programming and projects. We are creating the projects to solve the problems existing in the various business activities. Or the process may be done manually. To automate the existing manual process, we are going for computer-based systems or projects. So the input to the objective of any program or project is to solve the problem. So the problem is taken into consideration. We need to define the problem, and you have to analyze the problem. Then we have to create the problem statement. Once you understood the problem, then we will go for the solution methods. Taking the solutions, while looking for the solutions, we can choose any existing solutions, or already what kind of solutions methods the previous the to other people or other projects are using to solve the problem. Or if you want an efficient one, or you want to design your own problem solving method, we can design the algorithm. According to the algorithm, we can go for the coding. It involves creating a procedure or set of rules to solve the specific problem in a finite amount of time. So the thing is, the algorithm or the algorithm design what we are going to choose should solve the problem in a specific amount of time. It should not take longer time, or we cannot wait for the problem to be solved by the algorithm or the programmer for 1 year, 2 year, not like that. So the duration of the project or getting the solution to the problem is it should be done in a finite amount of time. Good algorithm design is crucial for efficient problem solving in computer science and other disciplines. In algorithm design, we need to follow some steps. Then only we will get an uh, advanced, or we can get an universal solution, so that it can be accepted by any people. Say the projects which are created by people in America or London, or in India, that is used by the programmers are from different parts of the country. They are creating the projects and they are providing the solution, apps and tools that is used by so many other country people, because it is they are following an standard techniques, or they are following an universally acceptable standards or quality assurance methods they are following. So to make your program universally acceptable, or to get an efficient solution that is acceptable by all kind of people, we need to follow a systematic approach, as well as we have to follow some standard steps. So what are all the steps we are following in algorithm design means? Any algorithm design should follow the problem. There should be a time duration for problem definition, or your team should work on the problem definition part. Then algorithm specification should be created, functional specification or non-functional specification. Then we have to choose the algorithm, and we have to analyze whether the algorithm is suitable for the given problem. Then we will go for implementation, coding, then perform the testing whether the chosen algorithm and the implementation is working perfectly with the given inputs and producing the expected outcome. So if it is not working properly, then we need to debug. We have to eliminate the errors and bugs. Then if it is producing some 50% of efficiency or 50% of the result, we need to iterate the same process. We have to apply some advanced concepts, so that it produces the maximum optimized solution. So these are all the steps involved in algorithm design. So definition means clearly understand and define the problem of the given project, and algorithm specification means formulate the steps or rules needed to solve the problem. Algorithm analysis involves evaluate the efficiency and correctness of the algorithm. Implementation deals with write the code to implement the algorithm, and testing and debugging means verify the algorithm works correctly and efficiently. Optimization means improve the algorithm to enhance the overall performance. So any doubt what is algorithm design? What are all the steps we need to follow in algorithmic design? Ayushri Singh. Any doubt? What is algorithm design? What are all the steps we need to follow? I told you, all of you, rename yourself, use your registration number followed by your name. Who is Ishan? So if your registration number is not there, you will not get the attendance. Based on the recordings, while entering the attendance, Ananba Mukherjee, mention your USN registration number. Vinayak Sharma. So the registration number should be there along with the name.
Okay, ma'am. Okay.
So any doubt in this particular slide? Say for example, how the algorithm design is done means, say you want to create an algorithm for sorting an array using the particular method called bubble sort. So the problem statement is sort an array of integers in ascending order. The input is an array of integers that may be in unsorted form. We need to sort it using bubble sort technique. First, we have to write the algorithmic steps. So the algorithm heading is given. The first algorithmic step is start with the first element of the array, compare the current element with the next element. So in bubble sort, what is the what do you mean by bubble sort? What is the literal meaning of bubbles? Say for example, in a tank, water tank, or some lake is there, or some river body is there. If you throw on stone, it will create an bubbles, or it will go in layers. Or if the same way you are given a set of numbers, the numbers are in unordered form. You have to make a bubble, or you have to shake, and you have to make the small numbers settle down in the top, and the big one goes to the down. So the people, how villages people used to separate the stones from the rice, or they will separate the grains if they are mixed with the stones during the harvesting. They will use some technique to settle down the stones in the end, and the grains in the beginning. Like that, in bubble sort, you will be given an unsorted array, list of numbers. You need to make some bubbles among the input values, and you have to make the values are getting settled in an ordered form, so that the smallest one is in the beginning, and highest greatest one settle down in the bottom. The third step is, if the current element is greater than the next element, then swap the number so that the smallest number comes first and the greatest number goes back. Move the next element and repeat the step 2 until the end of the array is reached. So the first number is compared with the second one, and if the second one is small, first one is greater, then we need to swap. Like that, the first number is compared with all other elements. Then during the first iteration, the first smallest number will be placed in its correct position, and the second number is compared with the remaining numbers, and second smallest number will be found, and that will be placed in the exact position. So like that, we will repeat the steps. So repeat steps 1 to 4 for all the elements in the array. End when no more elements need to be swapped in a complete pass through the array. The corresponding pseudocode for the bubble sort algorithm is given. So the procedure means it is a keyword. Procedure means it is a function. In Pascal, we will use the keywords procedure function. It means we are writing in, we have main program, then we are having the sub procedure or sub program. Procedure keyword followed by procedure name. Bubble sort is our procedure name. Within the bubble sort procedure, we are passing the following arguments: array and the list of integers. N is assigned to the length of the array. For I equal to 0, I less than 1, I n minus 1, repeat the process. We are taking one more for loop, j loop, j equal to 0, j to j n minus I minus 2. Say if you are taking 10 numbers, 0 to 9, I loop will be processed, and the j loop will take care of 0 to 10 minus I. Now I value is 0, so 10 minus 0 minus 2. So it will compare the first element with the next element. Now a of j is 0, and array j plus 1 means the first number is compared with the second number. If the second number is small, first number is greater, then we will, if the condition satisfied, then the second number is placed in the first position, first number is placed in the second position. So we'll compare the first number with the second number. If it is small, then swap. If it is greater, no need to swap. So the process will be repeated for I equal to 0, j second number to the last number, and when I become once, this third number to the last number, like that. Both the two for loops used to compare the first element with the remaining all elements, second element with the remaining all elements, third number with the remaining all array elements. Once all the array elements are sorted, then we'll return the array. Say for example, here we are taking an unsorted array of 53842. The first pass, we will compare the first number 5 with the second number 3. Well, I equal to 0, j equal to 1. First number and second number is compared. Here 3 is smaller number, 5 is bigger number. Then we will swap. Then 5 is compared with the next number 8. 8 is bigger, no need to swap. Now 8 is compared with the next number 4. Now 4 is small, we need to swap. Now 8 is compared with the last number 2. Now 2 is small, we need to swap. So when I equal to 0, j equal to 1, this process is done. Then the same way, I is 2, j is j plus 1, then the process will be repeated. Like that, I equal to 0, I equal to 1, I equal to 2, I equal to 3. The process will be repeated until all the numbers are sorted. Any doubt what is algorithm design?
Yeah.
Any doubt? Niranjan?
No, ma'am.
Any doubt in this topic? Once the algorithm is designed for the given problem, then we need to calculate the complexity of the algorithm in terms of time complexity and space complexity. Whatever algorithm we are going to use for our program, it should be an efficient one. And how we can identify a particular algorithm is efficient one means based on evaluating or calculating the time complexity and space complexity of that particular algorithm. So what is complexity means? Complexity means we know very well. If the process is very tough or a very complicated one, if it is tedious task, we will call it as complex. The same way we'll have complex numbers also. How we can evaluate the algorithmic complexity means it refers to the computational resources required by the algorithm to run. Because based on the algorithm only we are going to write the program and code. While executing and compiling the program, whatever instruction and steps we mentioned in our programming, that should be available. The various resources should be available to run the algorithm, which is typically measured in terms of time complexity and space complexity. So you are writing a program which is having where the project is very big, and if you are trying to load the program in a very lower version of the computer, And if the computer is not supporting the program, and if it requires some hardware, software peripherals, audio video systems, along with that project to run, then when the resources and the required components are not available, we cannot able to run the project. The same way, your project is good one, you should have minimum, you should have the minimum time, you should take minimum time, as well as it should occupy very less space to run the project. So understanding the complexity helps in evaluating the efficiency and scalability of the algorithm, and how many users can access the system at a time. And if a number of users restricted to the system is only, say for example, if you are taken a ATM machine, if people are continuously doing the transaction with the ATM machine, once the cache is over, or if the server is not supporting, the number of transactions assigned to that machine is ended, then the system will say the system is under service, contact nearby ATM machine, like that. So when the result is published, all the students are trying to access the website. Then if the server is not responding to all, then the hanging may happen. The algorithm complexity can be measured in terms of time complexity and space complexity. Time complexity means how much time the algorithm takes to execute and produce the output. And space complexity means how much memory space we need to store and run the program. Say if you are downloading an app through Play Store, we will check how much memory we need to download the particular app. Say if the app is in megabytes, say 12 MB or 14 MB, or if it is 25 MB, we may download. If the project is of 55 MB, or if it is more than 70 MB, like that, we cannot able to download and use it because it occupies more space. And if your mobile is low configured, it's not having enough memory space, we cannot able to download, or we cannot able to install also. So while creating any program, the time it takes to produce the output and the memory space it occupies to store the program, both places an important role. So time complexity represents the amount of time an algorithm takes to complete as a function of the length of the output, expressed using big O notation, which describes upper limit of the running time. In general, we are representing the time complexity by using big O notation or capital O notation. So that is mentioned as order of one, order of one. Some algorithms takes order of n log n or order of n square, or some quick sort and all, they will take order of n log n, like that. And if you take the space complexity of an algorithm, it represents the amount of memory an algorithm uses as a function of the length of the input. So how much memory space we need to download and install the software, and how much what is the maximum length of number of how many inputs we can accept, what is the minimum range, what is the maximum range. If the input exceeds the limit, what will happen to the system. So it includes both the space needed for input data as well as auxiliary space, temporary space used during the computation. So not only the program is stored in our memory, the input what we are giving, that is also stored in the memory. Then only the program accepts the input and it performs the task and produces the required output. So we need to calculate the memory required for installing the software, the memory needed for giving to store the inputs, and the memory used to store the outputs. Any doubt what is algorithm complexity, time complexity, and space complexity?
No, no.
Any doubt?
No, no.
So to understand the time complexity, The Zoom will end in another 10 minutes. Again, you need to join with the same link. To analyze the time complexity, we are taking the algorithm called bubble sort. So we are going to sort the given n numbers using bubble sort. In bubble sort, how much time we need to solve the given n numbers. So the sorting can be done in best case, or it can be done in average case, or it may be done in worst case. Say what is best case means, if it occupies very less space, as well as if the process is completed within 1 or 2 iterations, then it is called best case. So that is that particular thing is presented using based on the asymptotic notations. So we are using a notation called asymptotic notation that is used to represent the complexity of an time and space complexity of your algorithms. So what is this asymptotic notation means? It is an mathematical tool used to describe the limiting behavior of a function when the arguments tend towards a particular value or infinity. So using this notation, what we are doing, we are calculating the time required to run the program as well as the space required to store the program by using mathematical formulas. So the mathematical formula we are creating for the particular algorithm based on the various parameters, based on the minimum value, maximum value, as well as the average condition. Those notations are essentially in computer science for analyzing the performance and efficiency of algorithm. The asymptotic notations, particularly in terms of times and space complexity, the notations are used to represent the algorithm's performance. They provide a high-level understanding of the algorithm's behavior for large input size. So if the input given to the algorithm is exceeding exceeding about more than what is given, or for giving large data sets or giving maximum inputs to the program. In that case, the asymptotic notations are used to find out the how much time as well as how much space the algorithm needs with the minimum value, maximum value, as well as in the average value. So by taking all those parameters into consideration, we are creating a formula for n inputs in bubble sort. The runtime complexity will be order of n square, or in the same way, but in case of a binary sort, it will be order of n. If it is quick sort, it may be order of n by 2. Like that, we are making a formula subject to the conditions, and we are presenting the formula in terms of asymptotic notation. They provide a high-level understanding of the algorithm's behavior for large input sizes. So the common key notations are used for asymptotic representation. The three methods are big O method, big omega method, and big theta method. What is this big O method means? So here we are using the capital O. No? So that representation is called order of n square, or we call it as big O of n square. Big O means it is O is in capital, so we are calling it as big O notation. In big O, what it represents means it describes the upper bound of the algorithm's running time. So when you are running an algorithm or program, the maximum time it takes to run the project is taken into consideration for big O method. Say the same program may be executed within 3 minutes, or in some if you are giving only 10 inputs, the same programs you are running, and if you are giving 50 inputs, it may take 5 minutes. And if you are running the project and if you are giving 100 inputs, it may take maximum 10 minutes. So in that case, how we can find out the runtime of that particular algorithm with a smaller amount of inputs, average amount of inputs, and a very high amount of input means here, according to big O notation, we will take the upper bound. So if you are giving 100 inputs, if the algorithm takes 10 minutes, so the runtime complexity of this particular algorithm will be big O of n square, or big O of 10. So the maximum limit is considered in big O notation. It provides a worst case scenario for the growth rate of an algorithm, because we are taking the maximum time required to run produce the output. So it is called as worst case scenario. So any doubt what is big O notation? You understood what is the big O notation? Big O notation is an asymptotic notation. It is used to calculate the space and time complexity of any algorithm. While calculating the time and space complexity using big O notation, we will take the upper bound. The maximum time required to run the project is taken as the value. So if you are taking the maximum time as your will be the time of the particular algorithm, then it is called worst case. The next method is called big omega notation. Here we are using the symbol called omega symbol. Have you seen this symbol anywhere? What is this big omega notation? This omega symbol. What is this big omega notation symbol? Any doubt? This is an this omega, theta, alpha, beta. They are all symbols of Roman Roman letters or what? We are using a number of mathematical notations: alpha, beta, comma, theta, delta. So, but in case of omega notation of asymptotic representation, what we are doing in big O method, we are taking the upper bound, but here we are taking the lower bound. So, the minimum time required to run the project is taken as the time of that particular project. So, that is called big omega notation. It describes the lower bound of the algorithm's running time, and it provides the best case scenario for the given growth rate of the algorithm. So because we are taking the lower bound, minimum time required to run the project, so it is called best case scenario. Example, if an algorithm has time complexity of omega of n, it means that the best case time required grows linearly with the input size. So when the input size increases also, anyhow we are going to take the lowest value, the minimum time required to run the project as the runtime of the algorithm. So it is called best case. And if you take the theta notation, theta symbol, it describes the exact amount of time we need to run the project. So what we are doing, we are taking the lower bound as well as upper bound. We are adding both and divide by 2. We are getting the average time. So that average time may be exactly matching with the exact time needed to run the project. So in a theta notation, it provides the tight bound, meaning it gives both the upper and lower bounds of the growth rate of the algorithm. If an algorithm has a time complexity of theta of n log n, theta of n divided by log n, n log n, it means the time required grows proportionately to log n log n, the average case. So we'll take the upper bound as well as lower bound. We'll find out the average. Any doubt with respect to alpha, big O notation, big omega notation, and big theta notation?
No, ma'am. Ma'am, can you explain theta notation?
I cannot hear you properly.
Ma'am, can you explain theta notation again?
Yes. So the runtime and time and space complexity of any algorithm can be represented using asymptotic notation. So the Zoom meeting will end now. Again, you join.